Why can't we see stars in space? There are countless accounts of astronauts who have been in space, expecting to see thousands of stars twinkling brightly and brilliantly, far from Earth in the vastness of the universe. But instead, they saw only an eerie blackness. Images of the moon and no stars even led to serious suspicions that Neil Armstrong and Buzz Aldrin's moonwalk was just a staging. But this is not true. Let's now find out together why there is a very simple explanation for the fact that cameras and people do not see stars in space. Anyone who has ever seen the stunning photos of the Apollo 11 mission, in which Buzz Aldrin, Neil Armstrong, and Michael Collins flew to the moon, will have asked themselves this one question: why are there no stars in all those pictures? These images, among the most famous in spaceflight history, show an impressive lunar landscape, astronauts in their shimmering suits, and the dark vastness of space. But the starry sky we know from Earth is completely missing. But how can that be? On the moon, there is no atmosphere, no clouds, no haze. Actually, the starry sky should shine brighter and more beautiful than everywhere on Earth. Let's have a closer look at the pictures. This is an original image from 1969. The sky is pitch black. Not a single star is shining in the background. Actually, the picture should look like this. For some people, the lack of starry skies was a major reason to doubt the authenticity of the Apollo missions. The lack of stars supposedly indicated that the moon landing had been staged in a Hollywood studio. Neil Armstrong and his colleagues made no secret of the fact that they saw no stars in space. A quote from Neil Armstrong: "The sky is deep black when viewed from the moon, just as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen." Is there perhaps, after all, a very simple scientific explanation for the absence of stars? Also, videos show no stars. He was the loneliest man of all time. Bruce McCandless II embarked on a daring experiment in 1984. He was the first and still the only astronaut to fly through space all alone and without any safety device. To do so, McCandless used the then brand new Manned Maneuvering Unit, a nitrogen-powered jetpack developed by NASA, to allow astronauts to move freely in space. This historic moment was photographed and filmed, showing McCandless floating against a backdrop of space and Earth, resulting in some of the most iconic images in spaceflight history. Yet even in this video footage, McCandless is seen against a deep blackness, not a single star shining. It's a fascinating phenomenon that no twinkling starlight can be seen in photos and videos taken in space. One might assume that modern video technology, far more advanced than the cameras of 1969, should now be able to capture the stars in all their glory. But that is not the case. Astronauts living in the International Space Station also often see only a uniform dark blackness outside their protective space capsule. The real reason why no stars can be seen in space. The absence of stars in photos and videos from space is not evidence of manipulation and fraud or bad cameras. In fact, the real reason is hidden deep in the fundamentals of photography. Cameras, whether old or new, operate on certain principles to capture light. They use a combination of aperture, shutter speed, and ISO, often referred to as the exposure triangle. On the moon, for example, where there is no atmosphere to diffuse sunlight, lighting conditions are extreme. It is very bright during the day, and the surface of the moon and astronaut suits reflect sunlight strongly. The aperture controls how much light hits the camera's sensor. When there is strong brightness, such as that caused by reflective sunlight, it may need to be reduced to avoid overexposure. The shutter speed determines how long the sensor is exposed. Too long an exposure time in space will cause bright objects to overexpose and stars to blur due to motion. Finally, the ISO value affects the light sensitivity of the sensor. The high value may be useful in dark environments, but can cause noise in the image if the brightness is too high. To correctly expose bright objects, such as stars in space or on the moon, the camera settings must be adjusted. But that's not what Neil Armstrong and all the other filming and photographing astronauts did. As a result, less faint objects, such as stars, disappear in the background. Even professional photographers, which astronauts generally are not, would have to work in space with a sophisticated technique of shading, exposure, and angle to perfectly image the moon, stars, and all other objects. The idea of a professional photo team in space, using shaders and lights to shoot pictures for a lunar calendar, may seem quaint at the present moment. But who knows, maybe such scenarios will soon be a reality through projects like colonizing the moon. Let's go a little further, because this explanation is only one piece of the puzzle. It's not as if only pictures and videos can't represent the stars. Armstrong reported a blackness. Consequently, he didn't see stars with his own eyes either. The mystery of human perception. The reason why Neil Armstrong, Buzz Aldrin, and all the other brave astronauts in space did not see stars is due to an effect similar to the exposure triangle in photography. Just like cameras, our eyes automatically adjust to the brightest light sources in their environment. For example, when astronauts stand on the brightly lit side of the moon, their pupils contract due to the intense light, allowing less light from the distant stars to reach their eyes. Astronauts on the ISS are also familiar with this effect. While traveling in full sunlight or surrounded by bright artificial light sources, they too fail to see stars in space. Nevertheless, there are rare moments when the full beauty of the starry sky is revealed even to space travelers. In the shadow of the lunar lander. On the moon, when astronauts step into the shadow of a large rock or other object that filters enough light from its surroundings, their eyes begin to adjust to the darkness. At these moments, the starry sky slowly begins to reveal its mystery, and the infinite beauty of the universe becomes visible. Neil Armstrong experienced this for a small moment when he stood in the shadow of the lunar capsule, and astronauts on the ISS experience this change as soon as the space station enters the Earth's umbra. Try it out for yourself. You don't have to travel to space to experience the fascinating effects of light and darkness for yourself. You can perform a simple experiment at home to experience firsthand how our eyes react to different lighting conditions. Go into a dark room and give your eyes a few minutes to get used to the darkness. You'll find that after a while, you'll be able to make out more details in the room as your pupils dilate to take in more light. Now, take your phone and turn on the flashlight or screen and shine it directly into your eyes. Suddenly, the rest of the room that was visible a moment ago will be plunged into darkness. This is because your pupils immediately constrict to adjust to the bright light source, allowing less light to reach your eyes from the dimmer parts of the room. This experiment vividly demonstrates how our eyes constantly regulate light intake depending on what lighting conditions we are exposed to. It's the exact same mechanism that makes it difficult for astronauts to see stars when surrounded by the bright surface of the moon or the lights of the ISS. The velvety darkness of space. A quote from Chris Hadfield. It's an unfathomable blackness, as if it has texture. You feel like you could put your hand into it. One of the most fascinating and often quoted descriptions from astronauts who have experienced space is the feeling of looking into a velvety, inky black nothingness. This deep black of space is not simply the absence of light, but it seems almost tangible, as if one could reach inside. Experts explain this perception by the absence of any atmosphere to diffuse the light, combined with the absolute silence and emptiness of space. Without the usual visual cues and without the light scattering we know from Earth, space appears even denser and more impenetrable. The adjective velvety conveys a sense of depth and texture, almost as if space itself had a physical quality. Is it just the unusual, overwhelming experience of absolute darkness? Or is it something else that makes dark space seem velvety or like matter? Interstellar space is often referred to as empty, but that is not entirely accurate. While space is certainly much less dense than Earth's atmosphere, it's not completely devoid of matter. The space between stars contains a thin mixture of gas and dust. This medium is mostly hydrogen, but it also contains other elements and molecules. Microscopic particles, or cosmic dust particles, come from collisions between asteroids, exploding stars, and other cosmic events. High-energy particles appear as cosmic rays. These particles also come from a variety of sources, including the sun, other stars, and extragalactic phenomena. When describing a velvety impression of the void into which one can reach, a comparison with mysterious dark matter naturally suggests itself. dark matter cannot be observed directly, and it's not actually dark, but visible. It is noticeable only by its weight. Dark matter is distributed everywhere in space, including the apparently empty areas. Moreover, the void is filled with a mysterious carpet of energy called fluctuations in the quantum field. Particles constantly appear, neutralize, and disappear again in very short periods of time. They form a mysterious energy about which very little is known so far, and possibly also something like a glimmer. A quote from Buzz Aldrin. "It was black, but had something, like a velvety shimmer." These descriptions seem almost as if astronauts were capable of perceiving the mysterious shimmer of empty space, or a delicate material texture. This is only made possible by the absence of starlight, which otherwise outshines this mysterious blackness. Click subscribe for more stunning videos coming soon.